Hello and very good morning to all who have joined us in this webinar on power system losses, evaluation and mitigation. Um, we are hosting this webinar live from SARC Energy Center at Islamabad, Pakistan. I am Bilal Hussain. I am working as a research fellow at SARC Energy Center with main focus on South Asian power systems. I will be moderating this webinar today. Ladies and gentlemen, I would like to inform you the very aim of this webinar was to disseminate knowledge on the best practices and modern solutions to control power system losses, which is rather a burning and very top challenge for all the power system utilities across the world. In this webinar, we will discuss the main driver factors for power system losses in SARC region, and also that how some of the top performing utilities are tackling these challenges. Ladies and gentlemen, the issue of power system efficiency is very well debated and discussed across the world. It is a targeted focus for power system regulators, policymakers, utility companies, and consumers all alike. It has also been a well-addressed area both in academia and practice. For SARC region, this issue has a special significance owing to the fact that aggregate technical and commercial losses of SARC utilities are sizably higher than the world average. According to several statistics reporting sources, the average transmission and distribution losses in SARC region are around 17 to 18%, while the average is just 8 to 9% in the rest of the world. At the same time, a utility performing at operating above 25 to 30% losses is rather a common observation in SARC region. Although the regional performance has been improving over the last 10 years, but there is a long way to go ahead. Ladies and gentlemen, as most of us know that power system losses are mainly of two types, technical and commercial. Technical losses are inevitable but can be controlled through several actions which may comprise simple measures like good maintenance, routine audits, and proper load balancing at the distribution side, or certain specialized measures such as network reconfiguration, opting for high tension distribution, or switching to energy efficient transformers. However, these specialized measures are often time intensive and require a justification financially. On commercial side, there is always more space for utilities to act and improve. Generally, a strong collection system and check and balance reduces the commercial losses significantly. Today, modern technologies such as smart meters, artificial intelligence-based theft detection, automatic meter reading solutions, or GIS mapping can help utilities to improve their revenue collection practices by tracking the electricity theft. Also, there are a number of technological and operational solutions to discourage electricity pilferage. Today, we will have insights on all these aspects from experts who are with us in our webinar. Such knowledge, we hope, as SARC Energy Center, it will prove a great value addition for policymakers, regulators, researchers, and academia members, and other stakeholders from all SARC member states. Now moving on to the first part of our webinar, I have the pleasure of presence of Mr. Muhammad Naeem Malik, the Executive Head and Director of SARC Energy Center. Thank you very much, sir, for your kind time out of your busy schedule. I would like to invite you to please have a welcome speech.
Thank you. Thank you very much. My dear friends, participants, and presenters of this webinar, Assalamu alaikum, a very good morning, and namaskar. I welcome you all to this webinar on power system losses, evaluation, and mitigation. It's a great honor for me to speak on this important subject, especially in the backdrop of energy crisis in the region of around 2 billion people. It is expected that today's discussion will play its role in future development and prosperity of people of this region. Dear participants, first of all, allow me to briefly speak about SARC Energy Center and its responsibilities. The inception of the center as a regional institute and technical arm of the SARC organization on energy matters was approved in 2006. The center was expected to translate the vision of SARC leadership into reality with reference to energy related matters. The governing board, represented by the energy professionals from all the 8 member states, was constituted to guide and supervise the center. The day-to-day function control of the center lies with the SARC Secretariat. The center started its operation in 2008. During last 10 years, the center has emerged as a vibrant and effective SARC institute which has played its role in all regional level energy initiatives. Until 30th December 2017, the center has carried out over 100 interventions. The report of these interventions are available on center's website. In today's webinar on power system losses, evaluation and mitigation, we intend to discuss topics related to transmission and distribution utilities in South Asian countries. As you all know, all the SAARC member states are net deficit in energy and spend huge amount of their foreign exchange on its imports. It is worth mentioning that the region has huge potential, and besides meeting its own requirement, it can also export energy. Dear participants, energy is the prime mover of all economic and technological advancements across the globe. Consequently, it plays a crucial role in the development of human life. Economic growth in South Asia can only be ensured by making energy accessible, affordable, and reliable. The holistic view of the energy situation in South Asia reveals that optimal utilization of indigenous resources of regions needs to be prioritized since it would ensure and endure energy security and maximize the socio-economic benefits for the people of this region. Huge gap in power demand and supply in South Asia asks for new approaches, aggressive policy initiatives and decisions, as well as huge investment in the power generation and infrastructure development. In addition to short-term initiatives such as strict governance, energy efficiency, and conservation, off-grid and on-grid renewable energy projects, SAARC member states are also required to seriously focus on strategic power generation and cross-border power procurement projects. Power system losses or leakage decrease the supply of power to consumers and have adverse impact on financial viability of utility companies or impact the consumers in the form of higher tariff. South Asian countries are facing higher power system losses more than 15%, whereas international experience shows much lower losses. Non-technical losses can be controlled through policy, rule, and regulatory measures, whereas technical losses can be controlled by system upgradation. Dear participants, the objective of this webinar is to discuss on the types of power system losses, their evaluation, and its mitigation. In this webinar, we have invited experts from the SAARC region and outside the region. I would like to thank all the participants and especially the presenters of this webinar, especially Mr. Yogal Kishore, who is head of Siemens PTI Middle East, Mr. M.A. Rahman Khan, Power Systems Consultant, Mr. Pardon? Oh, it's okay. All right. Mr. Sanjay Kumar Banga, CEO, uh, TPDDL India, Mr. Sane uh, Gutiara, University of Technology Poland, Mr. Shah Zulfikar Haider, General Manager, Rural Electric Cooperatives. I would also like to welcome all other participants who have joined us today in this webinar. In the end, I thank all of you. My special thanks to the presenters and webinar participants. Lastly, I wish all of you a very pleasant day of knowledge sharing. I would request all of you uh, to ask as many questions as you want to create more clarity and to make this webinar more effective. Your suggestions will be welcomed, and we will be grateful for the suggestions given by you. May God bless people of South Asia and give us strength to serve them better. Thank you very much and best of luck and have a good day. Thank you very much.
Thank you very much, sir, for your welcome note and for explaining the role of SAP Energy Center in the regional energy context of South Asia. Uh, Now we will quickly move on to our presentations. But first of all, I would like to inform all the audience that you have the opportunity to ask questions. You can do that simply by putting in your questions on the GoToWebinar application window. You can ask questions during the presentation, but we will collect them and we will address them in the question answer sessions. It's also an information note for our resource persons that we will hold 2 question answer sessions after a couple of presentations. So we will request the first presenter to stay a while and join the question answer session and get the maximum benefit for the audience. Moving on to our first presenters, I would like to introduce Mr. Yugal Kishore. He is the technical lead engineer at Siemens LLC Abu Dhabi. He's an electrical engineer and holds an MBA. He has around 15 years of all-round experience and mostly with Siemens in its several formations, based in Pakistan and Abu Dhabi. Since October 2012, he has been working with Siemens Abu Dhabi, being responsible for developing the key areas of its business, including power system consultancy, software sales, and associated specialized power system analysis related trainings. He will be accompanied by Mr. Muhammad Abdur Rahman Khan, who is also a master's in electrical engineer and has international certifications on power system planning tools from Siemens. Since 2015, he is working with Siemens PTI Pakistan as power systems consultant. His employment experience includes K Electric, a distribution utility of Pakistan, and ENI Pakistan. So Mr. Kumar and Mr. Khan will be presenting on drivers of power system losses and modern technological solutions to address them. So I will be handing over the charge of the screen to you, sir. So you have the platform, Mr. Abdur Rahman Khan Saab, you have the control of the screens. Now you can start.
Hello, good morning. My name is Yugal Kishore. I am a technical lead engineer for Siemens Abu Dhabi. This is
Yeah, Mr. Khan and Mr. Kishore, we can listen you clearly. Uh, are you okay with the controls and do you have any problems?
Yeah, good morning. My name is Yugal Kishore from Siemens LLC, Abu Dhabi. Uh, I will just go through the some presentation slides, and the introduction has already been nicely given by the Mr. Bilal and his team. So with me, Mr. Abdurrahman, he will join me with the technical solution and the discussions. We will go through these power system losses and contribute solutions. In this one, we are going to discuss losses in electricity supply. What are the losses and type of losses? You have already explained nicely, but I will go in more detail over there. Then second is evaluation and assessment method for losses, how we are going to evaluate these losses, what are the best practices available over there. Then third one, we are going to talk about the loss mitigation strategies used by the different utilities across the globe. And then fourth steps, we will talk about the technologies, or let's say what best solutions or technologies available in the market in order to overcome such challenges over there. And then we will share the success story where we have worked with some utilities in Europe to reduce or let's say optimize the losses in the system. And next slide. Now coming to the what is losses, because this losses refers to the amount of electricity injected into the transmission and distribution system that are not paid by the user. These definitions can vary according to the behavior, or according to the country to country, how they translate this one. But this is generic, or let's say standard followed practice or definitions by the standard or most of the companies. There's two type of losses, as already explained or defined in the presentation, start of the presentation. There's a technical losses and the non-technical losses. Technical losses is due to the, most of the time we can say, due to the equipment itself, like a transformers or cables, or the these are the two major reason for technical losses. And the non-technical losses is there are a lot of reasons behind this one. The major consists of like electricity theft, non-payment of by customers, errors in accounting and record keepings. So these are the non-technical losses. Other than that, you can have say that due to the poor maintenance of the transformers, or poor connection or installation of the system, or poor selection of the equipments. These are the debate you can do it. This is different debate. Anybody can do it over there. So high losses means, when you are talking about the high losses in the system means, hello, hello. High losses means you have a less revenue for the amount of electricity generated. This also means increase in load and system. This means experience on the consumer behavior shows that electric consumption is reduced if consumers start paying the bills on time, or utilizing the energy utilized by them. So if they pay on the time, this means you are reducing the burden on the system, or the load on the system indirectly, in indirect way. Load I'm here referring means in the financial burden I'm talking about. Can you go to the next slide? So here we have just present the sum of the losses in the SARC region presented by the different entities, especially they have referred we are referring over is the World Bank figures over there. In the developed countries, the losses are in the range of 5 to 10%. But and especially in the SARC region, these losses are varies from 11 to 32% over there. If you look on the blue line on the top, this refers to the Nepal. If you look on the Nepal, it starts from 35%, approximately 35% of the losses starting in 2010, and it goes to 2014 in the range of, let's say, about still in the range of 30% over there. So similarly, other countries, for example, if you take over the Pakistan, if you look on the Pakistan, it in the 2000, it was in the range of around 23 or 25%, and in 2014 figures as per World Bank, it's in the range of around 15 to 70%, 17%. Similarly, you can take India. If you take an India, that they are starting around in 2000, it was around in the 20 or 21%, and then it reduced around, it's around now around 10%, or let's say on the bottleneck of the standard practices or in the standard. So these are the losses which is available in the SARC, like figures available in the World Bank, and these are related to the SARC regions over there. Next slide. So now we are going to talk about the evaluation of the our assessment method for the losses for transmission networks over there. One thing we have to be very clear, these are losses. There's no single best practice for losses calculation that can be followed. There's a different practices adopted by the different users across the globe. Someone will have a behavior that they can reduce the losses by proper selection of the equipment. Some will say, okay, we reduce the losses by proper balancing. Some will say we have reduced the losses by utilizing of the GIS interface and these kind of things. Someone will say that we have utilized the MDM system. Either you can say that load historian patterns. So this varies according to the behavior and customers and practices adopted by the different utilities across the globe. So increasing the precision loss calculation may add additional insight, seasonal variation, but also increase the cost and complexity of the analysis. Cost of the more detail may not be always provide more value when we are talking about the losses, reduction in the losses, because we always look from the losses across against the financial, like return on the revenue, or let's say financial analysis. Because if we select any equipment or anything, we look balance in the technical plus against the financial analysis. So these are the balance. You have to make a balance that might be you make investment much more, the losses will be reduced little. But either this is balance how you make it financial and technical. So that's why we always say the cost of the more detail may not always provide more value for these losses calculation, how you wanted to optimize over there. Key methodology used in the industry for the loss calculation is one is peak analysis. Peak analysis means you have a maximum demand available during that period, and develop the loss factor, how much energy is let's say you are losing or during that period. Not recommended as leading practice, as this method does not factor variable dispatch level and system configuration, because during the operation you can have a different variable loads or generation, or you can have a different configuration of the feedings over there. Then second method is multiple load levels. Run a number of power flow scenario with a seasonal load and resource data. Usually you can simulate 6 to 8 scenarios, like you have a peak, minimum load, maximum load, and you have intermediate scenarios, like and you can simulate and just compare it during that condition, what are the losses during that period also. Then another one is hourly load level scenario, and this is just like based on the historian load and resource data, security constant economic dispatch, and state estimator. So this is how you can do it. There's a different ways to do it. For example, nowadays the utilities are using, like you have a digital meters, and you have a UID, unique ID identification number. And these you bring into like directly or indirectly link with your power system analysis tool, read the data from there, and run your run your online, or let's say it's not online, or you can say completely, but it's a more accurate to the online simulations. And then you can run the load flow and short circuit load flow calculation and see that how much it varies. At the end, you will have a pattern of each individual. You can use it, either you can use as a grid, like you have a smart meter on the grid, and you have a pattern available, is hourly, or you can say it says 10 minutes every duration, whatever the historian available. Use that data and simulate the complete network, and that will give you a more insight how you can how much loss is in the system, and you can then take the measures from there. Some people, they say, okay, we can use the GIS interface and these kind of things. Yes, GIS interface is a mapping, or let's say is a creating a network into the ISRI or any software inside that one. But again, it depends upon the data quality, how well you have a data available for such kind of studies over there. My experience says most of the studies when we are doing over there, it does not have much more information available, or more assumptions are available to do such kind of things. Then coming to the distribution, software modeling for each feeder can be standardly and costly, as typical distribution network may contain tens of thousands of kilometers of distribution circuit sampling approach and widely used for the industry. Yes, that is a major challenge, major challenge. And also you have also another challenge is that and then the distribution network is so big, like a 30,000 substation, small distribution substation. When you start modeling, simulating might be your simulation tool on analyzing the data is a tedious work. It's not easy, because for the modeling you need 30,000 transformer data, accurate data, and this is really challenging to get all those data, because most of the time we say, okay, this is typical data used in countries, this is typical data, but this is not really coming to the accurate results. Again, these are more reliable results, but these are not accurate results what we are talking about. Then difference between the energy sent through the distribution feeder and energy meter at the end customer gives the total technical and non-technical losses for the particular feeders. And then computer simulation can then be approximate technical losses. This is what we are talking about. The best way is used across the globe is utilizing the power system tools, power system analysis tools, and then you link like using the SCADA system, or you can use the MDM, like a meter data, smart meters, and then bring those real-time data, or like to the softwares. Okay, I know these they are not 100% real time, but still after 2.5 minutes they can simulate it and give you a results. So at least you can say, okay, these are not 100% online system, but you can get the results very close to your reality. But this is again related to the cost, because when you are implementing the smart meters and bringing this IPs data and creating a UID and SAP system, or whatever the solution you have, IT system, so these are again related to the cost, how you are analyzing this one. Typical data required for the simulations substations are size, node load, iron, core losses, load copper, coil impedance, and voltage levels. These are just like a substation or distribution transformer you data require. Primary and secondary circuits, you have a conductor size, impedance definition, length, loading, and voltage class. Equipment data, loss data for buses, regulators, capacitors, and street lights. And then load data, load profile, power deliver and different times through the period of this one. There's a one, these are the most like a data we require. That's the most important factor, which is I can just share you, because now the air conditioning system, the concept of air conditioning system is increasing. So when you have anywhere the switch air conditioning, this means the air conditioning, okay, it will not impact the transmission system, but in direct distribution system, during the energy switching on and off, it's treated as a motor. So these kind of factors should also be considered when you are doing the losses calculations over there. So for the next slides, my colleague Abdurrahman will take over, and he will present the losses mitigation strategy and further technologies. I'm available for any questions after this presentation. I will be online.
Thanks, Mr. Yugal. Good morning, everyone. Like Mr. Yugal and other speakers have already explained that the losses are of two kinds, either technical or non-technical. Similarly, their mitigation measure also includes and targets either reducing the target losses technically or through some administrative measures. So moving on to the conventional strategies that are used by most of the utilities. So this include use of on-load tap changer, because changing the tap position of the power transformer can alter the reactive power flow through the transmission line. So if you set the power transformer tap changer at optimal position, it will draw less reactive power from the network, and the losses will be reduced. The second point is also related with the above, that you install capacitor banks closest to the load. where reactive power requirement is high, because whenever reactive power comes from a long distance, it causes active power voltage drop and active power losses, because although the losses are more related to the active component of the loss, but whenever reactive power flows in the system, it also creates a active power drop, voltage drop in the network as well. So if you install capacitor banks closest to the point where there are requirement for reactive power, it will reduce the loading on the line, and consequently the losses will be less. Third, you can also do to adjust the loading on each of the three-phase conductor, because if you reduce the unbalance between the phases, there will be less current through the neutral, and if there is no current through the neutral, then the losses will be minimized. Then you can also minimize the long low voltage transmission distribution line by installing either installing a low capacity distribution transformer, because in some utilities in Latin America, they have a dedicated low capacity transformer for each consumer. So this reduces uh, hooking in the transmission line, because you have energy meter installed at the so you cannot steal electricity from the distribution circuit. And also when there is a grid of medium voltage line instead of low voltage, then the line current will be reduced, and there consequently the losses will also be less. uh, One thing you can also do, that you can size the LT conductor in such a way that the maximum voltage drop from the source point till the end customer does not exceed 5%. If there are more voltage drops, then this means that there are more losses across the distribution line. So by controlling the voltage drop across the distribution line, you are actually controlling the losses as well. Then you can also use insulated cables or aerial bundle conductors, where there are distribution lines on overhead. So K Electric, a distribution company in Pakistan, have experimented this uh, of using aerial bundle conductor in an area where there are high losses, and the result is that they have controlled 90% of the losses in that particular area, because making hooking connection in a bare conductor is more easy in a comparison with making a tampering with a aerial bundle conductor or an insulated cable. Then you can also ensure that the energy meters are installed in vertical position, because if they are electromagnetic mechanical meters, and if they are not properly aligned, then the energy recorded by them will not be accurate. Then you have to replace defective analog meter with new digital meters, because analog meters degrades over time and records less energy over period of time. Then if you have a request for removing a connection, then you have to make sure that the meter is disconnected properly in time, so that the consumer do not start using energy again. Then you can also use bolted connector and eliminate wrapped wire connection, because if you have loose connection, then it will cause arcing, and arcing current will cause losses in the distribution circuit. Then you have to also make sure that the maintenance of distribution transformer are done periodically, because the condition of oil has to be proper, as it will reduce the heating effect within the transformer, and heating will cause losses in the distribution transformer. So periodic maintenance of transmission and distribution circuit, as well as the distribution transformer, is necessary. Then you have to trim trees which are touching the distribution lines, because they can damage the distribution circuit and cause arcing, which can also create losses in the distribution circuit. So these are the conventional strategies that are mostly adopted by major utilities, and as the technology is progressing, we have some more.
Mr. Khan, I just want to add that we have some time shortage. If you can wrap up quickly a bit the rest of the presentation, but thank you for listening.
Okay. Okay. So we have some technological revolution like advanced metering infrastructure and which provides the benefit of real-time monitoring of consumer meters, that how energy is flowing from source to the end customer. So you can actually monitor that whether the consumer is stealing electricity or not. Then from transmission circuit, you can employ HVDC transmission, which has lower transmission losses, and FEX devices like SVCs, which can regulate the power factor and consequently the reactive power in the transmission circuit. Then you can use gas insulated substation, which have lower footprint and can be contained in a basement of a building, so that the transmission can be done closer to the load. Then you can also use distributed generation, as means generating electricity closer to the load, so that the electricity does not have to travel a long distance from the generator to the load, and which will cause losses in the system. So Siemens have implemented a project in Brazil, Brazilian utility company, and it covers about 40% and transmit 69% of Brazil electricity supply. And the issue that they were facing, that the 22% of their electricity generated is lost in the transmission distribution circuit, and one of their utilities incurred around 39% of commercial losses. So what Siemens did, that they employed smart meters, meter data management, and smart grid equipment, including advanced metering infrastructure. So this resulted in overall reduction of losses from 31% to 29.8%. And if you converted that into amount, this approximate into Brazilian real around 28.8 million dollar, this around something around 6 million US dollar. So that is a huge saving of using modern technologies and advanced metering infrastructure. So that is from our side, and back to Mr. Bilal. Thanks.
Thank you very much. Thank you very much for such an insightful presentation. I would request you to stay with us till the question answer session. Now I would like to invite our next presenter. And,
but in the meanwhile, if anybody has any question for this presentation, let's await that because.
We can have one or two questions right now. But our resource persons are still with us. Maybe, sir, it's good if we can collect the two resource persons together and ask the questions, and everybody can share on them.
Sure, we are available.
Okay, thanks a lot. Okay, let me first introduce Mr. Sanjay Banga. He is the CEO at Tata Power Delhi Distribution Limited. The company has a registered customer base of 1.6 million, and it reaches out to over 7 million consumers in north and northwest part of Delhi through its services. Mr. Banga is an electrical engineer and holds an MBA. He has been with Tata Power DDL since July 2003 and was part of founding team which transformed the ailing distribution company into a benchmark utility. He has over 3 decades of generation and distribution sector experience. He is also a member of Indian Standard Core Committee for defining standards for power system control and communication. Mr. Sanjay will share with us the interesting success story of Tata Power Delhi Distribution Company as it controlled its system losses and improved efficiency. So over to you, Mr. Sanjay Banga. I am handing over you the screen rights.
So good afternoon as per Indian time to everyone. It's a pleasure to share what we have done in last 16 years in Tata Power Delhi. I will discuss how this company was formed, what was the transition model from government company to private company, and then what we have done so the losses reduced from 55%, I would say, to 8.4%, which we close in this year. So they all you all can see the presentation.
Yes, sir, we can see the presentation all right.
Okay, so to start, I am on slide 2. So this company is a 51-49% joint venture between Tata Power and Government of Delhi. So Delhi government has 49% here. Management of company is entirely with Tata Power. The board consists of 4 members from Delhi government and around 5 members from Tata Power. This gives you the next slide, which is slide number 3. This gives you the idea of last 16-year journey, and if you see the key parameters, which are July 02 and March 18. So losses have come down from 53% to 8.4%. The demand has gone up from 930 megawatt to 1850 megawatt. In fact, yesterday we touched a peak of 1960 megawatt. The key commercial performance parameter, if you see the new connection time, which used to take around 2 months in 2002, has now reduced to 2 days. In fact, in ease of doing business on electricity, we are ranked on 29th in World Bank ranking. Consumer satisfaction index is fairly good, 91% consumer satisfaction index. Our consumer base is around 1.7 million. And the employee, the last row, if you see, the employee strength has reduced from 5,600 to 3,200. So all in last 16 years, while the peak load has gone up by more than 100%, the losses have come down to 8.4%. Reliability has gone to almost 100%. And all commercial parameters, if you see, there is a jump of almost 100%. Now, how this was made possible, if we go to the next slide. So next slide shows just, it depicts the picture of 2002, how bad the network was. And if you go to the next slide, then it shows in 2002 this company was formed, and the modality of forming this company was 100% owned by earlier Delhi Vidyut Board. The government of Delhi formed a new company called DPCL, the Delhi Power Corporation Limited. And that DPCL, actually, all assets were transferred to 3 distribution companies. 2 distribution companies are from BSES and 1 is from Tata Power. So all assets were transferred on business valuation methods, not on the exact asset value. License was for 25 years, and the condition of the business was we had to reduce losses as per the target which was given by DRC, or which we had in fact submitted in our bid document, and we were supposed to get 16% return on the equity. So whatever capex we invested, which was approved by regulator, the 16% return on the equity part, not on the debt part, was passed to us. The initial challenges when we took over was reliability, as I said, was low. There was no technology which was available in this distribution company. We hardly had any IT infrastructure in any of the offices. The commercial process were completely decentralized, and the customer needs were not, I would say, identified, or no one was worried about the customers. So that was a big concern. The employee ecosystem was not based on the performance. And when we took action, this is the trajectory on the next slide. If you go, the losses have come down over a period of time, and every year the target which we achieved is better than the DRC target. The next slide is exactly where I want to discuss more with you. In 2002, when we took over, the first thing which we started doing was on 2 fronts. One, on the employee front, where we took large workshop with the employees and tried to change their mindset that they have to turn from a comfort culture to the performance-based culture. And second, on the network, we invested hugely, both on reliability also, and also on all technologies which were leading to reduction in AT&C losses. So first 2 years we replaced all meters, and when we replaced meters in first 2 years, so then you, if you see the reduction in third year in AT&C losses, which was maximum around 11%. We did the metering right from 33 kV level, 11 kV level, distribution transformer level, and then the consumer level, and did the consumer indexing. So all consumers were mapped by using GIS technologies, right from their meter premises to the pole to distribution transformer to feeder, and we started getting report on the energy audit. So this gave us an indication that which transformer is incurring what level of losses, and that gave a target area to the zonal manager or subdivisional managers, that where they actually have to attack and curb the theft. So once this was done, some of the loss prone area, where the area which was tough to crack, we did the high voltage distribution system. So the small capacity transformer with insulated cables were installed, and the bare conductors were replaced with these HVDS system or high voltage distribution system that help us to reduce losses. And then the automated meter reading we did for all our consumer. The consumer profile of Tata Power Delhi is roughly around out of 1.6 million consumer, I would say around 100,000 consumers give us around 70% revenue. So this 100,000 numbers of consumers, we installed meters, and we also installed modems, and we started taking their reading at remote end, and we set up a analyst group with a strength of roughly around 30-40 engineers, and they did a lot of analysis of their meter consumption. This actually has helped us to pinpoint the loss, the consumers who were stealing power, and our loss level to these consumers have reduced virtually to zero or to a level of technical loss only. Then we started controlling on the low consumption, high consumer base, which we call is HCB consumer. And there we followed a policy of very aggressive enforcement, and we reduced losses there. And that reduction of losses was mainly from 2004 to 2008. And around 2007-8, to further reduce losses from the slum areas, we formed a special consumer group. So in this slide, if you find, you will find a milestone where it is written special consumer group. So this special consumer group is a group which interact with the slum people, and we observed there that they are not having a paying capacity to pay bills. So we engage them more in improving their paying capacity. We opened around 50 vocational training center. We opened around 300 women literacy center there, and started working with them to improve their income level. Over a period of time, I would say now if you see, our collection from these slum areas is around 80 to 85%. So loss level in those areas have also come down from almost 80% to 15-16% level. Further moving in around 2009-10, we completed the technology roadmap, where we implemented the SCADA DMS system for controlling all our grid stations and 11 kV substations from remote location. We implemented outage management system, which has a prediction engine of identifying which consumer is not having power, and integrated with the SCADA DMS system to minimize outages. And now our plan is to roll out the smart metering in next 5 years. I will go to the next slide. Just one question. Do we want to have a question answer session after presentation, or we can have the question right now after question?
Okay. Sir, as you finish your presentation, we will start with a question answer session.
Thank you. The next slide is just how the situation was, and how we invested in network infrastructure and changed the network. Then the next slide is the legacy infrastructure, how it changed to the existing infrastructure. So all oil circuit breakers were changed to ring main units from Schneider, Siemens, ABB. Next slide is all grids, as I mentioned, were automated and fully controlled from the SCADA control center. We have all our 75 substations, 66 by 11 kV or 33 by 11 kV substations. These all are unmanned, locked, and controlled from the central control center. Next slide give you that how integrated the technology landscape in Tata Power Delhi is. The GIS system is the base for all other systems. It has all the network mapped very accurately, which is a very tough task. And all consumers are mapped. You can see the red line and pointing to consumers there. This GIS data is used by OMS system and the SCADA system. The SCADA system, which I have shown here, is also now changed to Advanced Distribution Management System from G. And this SCADA system and OMS system are now integrated in Tata Power Delhi. So all GIS data or network, electrical network, as it is used by ADMS system, Advanced Distribution Management System, which is a combination of OMS and SCADA system. And consumer calls which are received in ADMS system goes to the field crew, and field crew using his mobile device closes the outages and update into the SAP call center. SAP, so all outages are known to call center. If any outages which take place in 66 kV level or 33 kV level is also known to the call center, because the OMS SCADA or the ADMS system is connected to the SAP CRM system. We also have the commercial software application, which is SAP ISU billing application, which uses the GIS data for consumer mapping to the distribution transformers. So the energy consumption of consumer and energy consumption of distribution transformer is used for generating energy audit reports in SAP system. If you go to the next slide, then I have just mentioned that how we discussed about how we are using automated metering reading system. And for the normal consumer, we use a mobile metering system where he goes, he punches the meter reading, and it then do some validation checks with the SAP billing system in data center, and have those kind of quality checks so that someone cannot punch the wrong reading. The next slide is again the 70% revenue coming from the remote metering system. This 55,000 is actually has now gone up to around 90,000. GIS system, as I said, next slide, is the base for all our systems. We use even the network planning application, the SIMDIST, which uses the GIS system. Next slide goes, and it tells you all the technologies which we are using in our Tata Power Delhi to improve reliability and reduce losses. So which includes SCADA OMS system, the demand side management system, geographical information system, automatic meter reading system, which now has a life of 1 year only because we are going for a smart metering system now. The next slide is again how the connection efficiency has improved, that anyone who asks for connection, we only take 2 documents of his premises and 1 application and give him instant connection. The dues checking and other formalities are done automatically in billing application itself. Next slide again shows you that how the technology initiatives which we have taken for consumer convenience.
10 seconds.
And the next slide, if you go, is on social innovation part, which I discussed that we have 223 slum clusters, and in those clusters we improve billing and collection efficiency both by more engagement with them, not by enforcement. And this is a kind of a innovation model which has been appreciated by government of India also. So a lot of initiatives taken for society, which has actually helped us in improving business performance parameters. Next slide is or the different initiatives we take for the society, which helped us to improve our performance and helped us to engage more with society. The revenue which you see has gone up in the next slide uh, from 0.13 million to almost 24 million USD. The next slide shows that how we believe in learning from others, because when we started, in fact, the Tata Power was not having much experience in distribution sector. We had a small distribution set up in Mumbai and were mainly involved in the transmission and generation, and Delhi was the first where we started distribution. And in fact, that has given us an advantage of starting afresh. And we tie up with many institutions, both academia and the industrial institutions, and started learning from them. The entire technology roadmap which we set up was in collaboration with Kima Consulting US and Quanta Technology in US. We have a tie-up with many utilities. We have a tie-up with NIL. We have a tie-up with the San Diego Gas and Electric, where we do the employee exchange plan and program, and we learn from them and implement their best practices here. The training center we set up in initial years here has a capability of uh, online training also. So someone who wants to really learn how the cable is to be laid, how the overhead transmission distribution line is to be laid, how the transformer maintenance is to be done. Those are the kind of a training which we provide in the simulated environment here. And this training center is now used for external training also, and we have delegates from all over Asia, from Afghanistan, from Nepal, from Bhutan. The next slide, if you go, is how we believe in learning again. So there is a higher education which we provide to employees. There is a mentoring setup which we have, that all young employees have a mentor in our company, and they are mentored by senior executives. The next slide, if you see, is how we are collaborating with almost 13 utilities across the world, which have utilities from US also, Europe also, Asia. Capco is there, and we have a discussion with them once in a year and discuss what's going around in distribution sector in different part of the world, how the utility business is changing because of the impact of new technologies, the new ecosystem of renewable and mobility, what steps each utility is taking in terms of influencing regulators and government. And those learnings we share here also with government and regulators, and that helps us in our business processes. So another slide is just on that only, and this is a recognition that this company is a good place to work. uh, And now, whatever we have learned in last 16 years, we have started working with most of the distribution utilities in India and some utilities in Africa, Bangladesh also, where we have started providing technology consulting to them in terms of IT and OT both. So we are the management consultant for 4 distribution utilities in Nigeria, and we are involved with Rwanda, Mozambique, and also some few other African countries like Zanzibar, where we are providing them how the network planning is to be done because of renewable, and what kind of a national distribution system they should have. In India, we are involved with almost 30 distribution utilities and giving them consulting services, and also the training facilities we provide them to equip them with better resources. This is just how we have been recognized. The next slide. I think that's all I have, and I'm open to questions from your end now.
Thank you very much, sir, for this insightful session. Mr. Naeem Malik will first start the question answer session, and yes, sir, it's working.
Okay. Thank you very much, Sanjay Ranga. It was a very useful, very impressive presentation. And my congratulations from the Sark Energy Center for the impressive work done by your company in controlling the financial losses. I have few questions.
Thank you.
I will ask. I will ask one by one.
Okay.
One is that while your newly formed company was taking corrective measures with reference to infrastructure and also was taking administrative measures within the company, what was the public or consumer reaction while you are doing all that work?
When we took over in 2002, actually the power scenario in Delhi was very bad. There used to be around 4 to 6 hours of outages. And as usual in developing country, when this sector is privatized, the issue is always takes a political turn. So there were, while the opposition parties were against privatization, the consumer expectation from this company were very high, and they were thinking the very next day they will start getting 24 by 7 supply. It was a tough challenge to meet those expectations, and our strategy in first 1 year was mainly to do lot of maintenance for the existing assets and improve the reliability so that the 6 or 4 hours of outages can be reduced to half an hour or no outages in fact. And there was no focus from our side in the first 1 year on enforcement or on the loss reduction. And the first 1 year is only on improving reliability and revamping all our consumer care center or complaint center so that the consumer should have a feel or have a point where he could be listened by utility. Because before that they had no listening post, I would say. There was no one who was listening to their complaints. And that improvement, when consumers started finding in the first 6 months only, we find that gradually they become partner to us. So first 2 years were very challenging in terms of meeting customer expectation. The employees which were not working and were completely taken over by us, because as per transition condition, all those employees who were with the government department were taken, and there was a condition that employees will be taken out. So we inducted almost 500 engineers in the first year itself, because we wanted to do two things. One, to change the mindset of these government employees. At the same time, pace the work, we wanted few change agents from the outside, so bring a healthy competition in the beginning itself to change our culture which was there. I hope I answered your.
Oh, yes, just very good reply, very comprehensive reply. And the good thing which happened was that the 500 employees which were brought from outside changed the culture, and they did not adopt the culture of the company, which was the previous culture. That is the great thing. You were able to do it tactfully. But one thing which I would further like to ask, that what was, though that initially the consumers started feeling that there is someone who can listen to their complaint and who can attend to their complaint. Uh, uh, but what was the ultimate impact of consumer tariff by the end of the day? And also, what was your profitability of the utility company with those actions?
Okay. So I would say before 2002 there was no concept of call center. So a consumer had to if he has any problem, if he had any problem, he had to call a complaint center in a local area and convey his problem to the representative of company. We did two things in a very second or third month was to first open a call center where he can call and lodge his complaint, and second, we made sure that all complaint center or the consumer care center which we had in our local area are actually have good infrastructure where the customer can come and sit there, because even those condition of those offices were very bad. And these two things were actually visible to the consumer. So they started feeling that there is some good change in this company from the third or fourth month itself. And I think that has helped us a lot in that.
Mhm.
In
So
terms
my,
of
my
your
question now,
question
Tariff,
on
consumer
profit,
tariff, your
consumer
profit, company's profit.
the first 5 years, the tariff hike was not there as such. Uh, the utilities were given only target of reduction of losses. So if we meet those losses, then we were getting 16% return on equity. So very next year onward, when we invested, we were actually getting money in that. And the transition condition was if the loss level decided by regulator is, let's say, 35% in year 2003, and we meet a figure of 30%. For the 5% which we were collecting extra, there was a sharing of 50% on that with Delhi government. So the business model is like that. If you meet loss AT&C or the T&D target, then you are making money. Tariff actually increased from 2007-8 onward, when it was told that the power procurement will be done by distribution companies. Till 2007, the power was procured by state government and it was given to us, and we were supposed to pay them the cost on the capability wise, that how much we can pay them, and how much we can pay them was decided if we meet our loss level, which was in the multi-year tariff. It was known that how much revenue we will be giving, and that revenue was passed on to the generator. Government was knowing that there would be some gap on that, and they had given a transition support of roughly around 300 3,000 Indian crores, or I don't know how much you will convert in around $50 million.
Okay. So tariff reduction because of decrease in losses was not passed on to the consumer as such,
Uh,
right?
the tariff
Is it so?
reduction because of AT&C loss reduction was actually balanced uh, with the transition support. The state government was knowing that we will not able to recover the money to pay to the generator, so they had kept a corpus on which they were funding the Genco. So whatever the losses which we were reducing, the corpus which they had fixed in 2002, that if I meet my target, this is the extra money which is required to given to Genco. They paid that money. 2007 onward, it was completely made free that now Discom has to buy power and they have to manage the power purchase cost. And 2007 onward, if you see, there were we asked for the tariff hike because at that time also the generation price had also gone up, but largely because the tariff because the losses have reduced from 53% to almost 20% level by 2010-11. It helped us to curb the increase in the tariff. So tariff, if you see in Delhi, is very less as compared to nearby area. When you compare it with the power purchase cost, the power purchase cost, Tata Power is highest in India because Delhi doesn't have a localized power plants. It gets the power from the remote place and the transportation cost is very high. But still, because the losses are 8%, our tariff is comparable and in some categories less than the nearby area.
Okay, okay. And what was the total initial capital cost of the infrastructure improvement?
So the capex we invested in Indian terms is around 400 crores per year. So 400 crores means
We
around
can convert it that. We
70
can
million
convert it to
dollars.
dollars. No? $70 million per year.
Yeah.
And for how many years you continued investing?
Almost every year. And this year also it is almost same. Only earlier it was more on the network improvement, and now it is more on the technology and smart metering.
Okay, all right. And what is percentage of bill recovery from the consumers in your area?
Our billing efficiency is around 92%. Our collection efficiency
Like,
is 100%.
so your billing efficiency means 92% consumers pay. Hello?
Yes.
Uh, 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 does it mean that 92% consumers pay?
No, it's not like that. It means that if
Means
my
that
input energy is 100 million unit, then
mm,
92 million units I am able to bill.
you are able to bill.
Yeah.
And what about remaining 8%?
Remaining 8%, there would be 5 million units will be the technical loss, which is applicable to every
So,
utility, and around
so
3.4 is the
brother,
commercial loss. So I'm not able to bill it because
so
of the loss or the theft by
loss.
consumer.
Okay. Besides losses, these 8%, do you have cases where consumers, which may be the public sector consumers or private sector consumers, when you raise the invoice, they don't pay?
Yeah, these are the cases because when I'm saying 100%, it includes area also. So there, like any other developing country, there are consumers who default, and there is a process for that. That if they don't pay for the next one month, they are sent the disconnection notice. If they further don't pay by next billing cycle, then we give them the disconnection order. So there are entire commercial department is process is made of 9 departments, right from meter reading, meter installation, meter reading, revenue recovery, the enforcement. So the entire commercial business process are mapped in such a way that when the meter is installed and consumer pays them, there is a group who is responsible for each of these activities. And all
Great,
these.
great. Thank you very much, Mr. Sanjay. And I'm grateful for your patience and giving reply of all those questions which I raised. Maybe some other participants would raise questions. Over to you, Ji.
So we indeed have several questions received. I would like to inform that our initial presenters are also with us, and I would pose this question to all of our presenters that what is the role of automatic demand response in terms of power system loss reduction? Can you share your experiences? And please, all the presenters, please share one by one.
Okay. So in automatic demand response, we installed around we selected initially around 250 consumers with each having a demand of more than 100 kilowatt. We segregated their load in essential and non-essential load and had a controller in their premises, and we installed the smart meter who was reading the consumption pattern of that consumer, and from the centralized location, we had a we could control their demand. We had an agreement with these 250 consumers that when we want, we will inform them half an hour in advance, and we will cut their non-essential load. We did that exercise for 2-3 times when we had a power supply issue, and we reduced it by 15 megawatt for this 250 consumer. We did that around 2 years back. These controllers are still there, and we find that the pilot project which we did was successful in terms of demonstration of technology. Unfortunately, in last 2 years, because of our power tie-ups, we are never short of power. So there is not and in India, your power supply is 90% is long-term power purchase agreements. So these plants give you supply. Only the 10% is where you may decide to buy from exchange. In case of Delhi, it is actually more than 100% the long-term power purchase agreement. So in last 2 years, we are never short of power supply in a way that we need to resort to automatic demand response. So if you ask me how much loss reduction it has done to us, we don't have that case with us right now.
Thank you, sir. If Mr. Yugal Kishore and Muhammad Abdul Rahman Khan Sahab has any comments to share, please. Mr. Kishore, are you with us?
Hi. Yes. This
Yeah.
what Mr. Sanjay has described very well. This the concept of automatic demand response. This exactly depend upon the availability of the energy and how you manage it in at the end. So this will definitely reduce your losses. Percentage wise, I cannot tell you that how much it will reduce, but definitely this reduce the losses of the system overall. Like for example, in some of the area, for example, you have an area where you are utilizing pattern, for example, a demand is very high during certain period of time, and this means you are loading your equipments such amount of this extent. So this means their losses will proportionally, or let's say directly or indirectly, increasing over there. So in order to regulate, you can use this concept of this automatic demand response curve. There's a new concept now, this is coming up, which is called this VPP concept, where Sanjay is saying that we have a sufficient generation and we don't have a area where we have a shortage of the power or very increase of the power. They have a balance of the power. Now, virtual power plant concept is just like you are creating a concept of the virtual power plants over there, and you are like at the end, this is the same controlling concept, but what you are doing is you are managing the power using the virtual concept, that if some area don't have a utilization of the power, you transfer those power directly or indirectly using the virtual concept to the areas where the high demands are there. So you are managing that concept and are also reducing this energy also. But at the end, the concept behind this one is the same.
Perfect.
Thank you, Mr. Kumar. The next question is from Nepal, and it's regarding the best conductor choice for the distribution sector, especially considering the power system loss reduction aspects.
I couldn't get your point.
The question is asked that can you recommend the best conductor for distribution side that has the best loss reduction potentials?
I think that depends upon the current capacity you want. And there are the standard conductors which are mentioned that for this capacity, this conductor is to be used. In India, we have IS standards, and those IS standards define that. I can do that. I can send my engineering person to send those guidelines that what kind of a conductor we are using for what current capacity, and that could be helpful to you.
I would.
That's great.
Sorry, can I answer this in different way? Okay, Sanjay
Please.
has told that in selection in one way that is correct, that rating based on the rating and these kind of things. The another aspect is not only conductor selection, how you put the load, where you are putting the load center, that is most also important. Because if you are putting the very big conductors like a 30 kilometers cables, or let's say OHL ABC conductor, or whatever the conductor you are utilizing over there, and you are putting a load center very far, in that case you have a more energy losses. So selection is not only on the current rating over there, but also the voltage ratings and the sheathings and the losses of the conductor itself. So selection of the conductor is not based on the one criteria, only
I
on the
think
ratings.
that would be a part of the network planning. That when you are laying your network, you have to see how long you want to take the 11 kV feeder or the LT feeder. What would be the voltage profile at the fag end? That is a part of the in our what you are saying is very correct. But we consider that as a part of our network planning. But we plan a network, we have to see there is a load balancing, because until or unless we do that, the technical losses are not minimized.
I agree, fully agree. So the concept is only not the most of the people, they think that only the selection of the conductor like based on the MP rating will solve the problem. Is not. So that is why I'm
That
just putting in, this is planning part. They have to do it, and then they come to the conductor like a type, which quality, like which cross section, which impedance, which is offering less impedance, which is giving me a good load factor, how I can lay like a soil resistivity, and these kind of factor all the comes later on when they are installing, and these comes. I agree with you.
Another thing that I would like to add, that with respect to conductor, we also have to consider that which conductor we are using. Like are we using copper or aluminium? Because what we experience here in Karachi, that earlier in distribution system we use a bare copper conductor, so which was more prone to theft because copper has a good market value. So K Electric, the distribution company here in Karachi, replaced copper conductor with aluminium conductor, and they have to make sure that the conductor which is being replaced has the same current rating and has same electrical characteristic. But we have to consider that this aspect as well, that the use that conductor which does not invite more theft of conductor. So this also has to be considered.
very
Okay, thanks a lot, sir. So I will quickly wrap up this question answer session with the last question from Mr. Asad Mahmood from Pakistan, and it's directly addressed to Mr. Sanjay. It's that please shed some light on the impact of bill financing for energy efficient appliances.
okay. So in India, we have a BIS, Bureau of Indian Standards, and they have defined the rating to appliances. So if a 5-star appliance is there, its energy consumption is almost 40-50% of a normal appliance, and those star ratings comes for all appliances like refrigerator, air conditioner, and even the transformers which we use. The regulator has said that you should use the not less than 3-star rated transformers, because those are in those transformers the loss level for a particular capacity is less. What we have done in Tata Power Delhi is we have taken an approval from regulator to for certain capex amount, where the regulator had said, okay, I am giving you this capex to promote the demand side management. And in that, what we do is we use that money to fund air conditioner, and those air conditioners are 5-star rated air conditioners. So any consumer who is having a normal air conditioner can give back his AC and take the 5-star almost at the same price. Other thing which we are doing is we in our consumer care center we have a stall where we give them the LED bulbs. So any consumer of Tata Power Daily can come and at discounted price can take the LED bulbs instead of they can replace it with the conventional bulb as well. And same is applicable for fans, where we give a fan which has a consumption of almost 50% than the normal consumption. And the capex funding for this comes from the regulator for the promotion of demand side management or energy efficiency.
For valuable thoughts you've shared, and I'm indeed very thankful to our presenters from Siemens and from Tata Power Distribution Company. So now we will move on to the next phase of the webinar. I will invite Mr. Sunny Katiara. I will also request other presenters who have already presented that if you would remain with us, and then there will be a question answer session in the end if you would like to participate in that as well. So, short introduction of Mr. Sunny Katiara. Mr. Sunny Katiara is a young electrical engineer and a lecturer at IBA University, Pakistan, and also an Erasmus Mundus Scholar at Wroclaw University of Science and Technology, Poland. He has research strengths in power quality assessments and distributed generation modeling and analysis. He has recently modeled the effects of unbalanced loading in SEPCO utility of Pakistan and published his research. Mr. Sunny will be presenting brief on effects of unbalanced loading on power system losses and an interesting case study of SEPCO Pakistan. Um, well, I have to inform that Mr. Sunny is not with us right now. He's facing some internet problems. So maybe if I would request Mr. Shah Zulfikar Haider, if he's with us, to start their session first. I would, Mr. Shah Zulfikar Haider, are you with us, sir? Mr. Haider? Okay. Um, so we have Mr. Sunny Katiara back, and he has joined us. So greetings, Mr. Sunny Katiara. Are you with us? Can you hear us?
Yes, I can hear you.
Okay, I have introduced you already, so maybe you can proceed with your presentation now.
Yeah, exactly, because I have some other commitments and I have to go there. I'm just waiting for your this presentation.
I'm indeed, I understand. We had a little problem with the time, so maybe if you can quickly start with your presentation now. Thank you very much.
Yes, quickly. No, no, it's fine. It's fine. Just I have some problem with my internet too, so I'll just quickly going through my presentation. So, hello everyone, and I hope you all are good and doing well. So, my name is Sunny Katiara, and I have done my master's on Erasmus Mundus from Wroclaw University of Science and Technology, and at present I'm serving as a lecturer at Sakhar IB University, Pakistan. So, from my side, the today is the topic of webinar is effects of unbalanced loading on network losses in Pakistan and how they are damaging the power economics of power systems. So we are going to discuss about it. So here are the contents of my today's presentation. First, we are going to introduce the basic types of losses and their prime causes, and how the unbalanced loading is actually affecting these losses. And then some case study, like we have taken a one case study considering the SEPCO network, which is one of the distribution network in Pakistan, which is the worst one, so that I have chosen, and some facts and figures from the Pakistani network, and then the remedies, and finally your queries. So coming towards the first slide, that is about the introduction. So on broadly, the losses are actually being divided into two parts. The first are the technical losses and another are the non-technical losses. So the technical losses are those losses which are actually occurs due to the flow of current when the current interact with the physical properties of the system, like its resistance, its reactance. With this interaction, these type of losses occurs. And these are the natural losses. Actually, these are controllable and they are measurable, but we cannot actually completely eliminate them. What are the types of these losses? Like copper losses, I square R losses, dielectric losses, which are occurring due to the dielectric material, which are nowadays being used as an insulation material in different electrical equipments. And then there are the induction losses and radiation losses, which are occurring due to the surrounding of magnetic fields. So these are some types of technical losses, and what are their probable causes? How these losses actually technical are occurring? Like harmonic distortion is one of the cause for these technical losses. Then the improper earthing at the consumer side, like the consumers have different. If the consumers, when we have different consumers in the distribution network, and if all the consumers have different earth resistance, then it's called the improper earthing. Due to this unlikely resistance in the earthing. It causes the a mismatching between the earthing resistance, and there is a current in the neutral winding, and there is an unbalanced loading, which is actually a main cause nowadays in Pakistan, that is causing the huge power losses in the Pakistan, because you know that the single phase loads are always being connected, and then is a overloading due to the overloading of the lines, and then there is under voltage, and the final is a poor standards of the equipments due to the, and they are violating the compatibility of the equipments with the grid codes. And then are the non-technical losses. Non-technical losses are actually those losses which are out of the power system, means they are not in our control, we cannot control them, like the power theft, which is actually a you can say a mainstream in the non-technical losses, and it is actually a big issue even in the Pakistan. And how this can be this can occur, like due to the meter tampering, we can temper the metering, and we can play with the meter, or we can bypass the meters, or we can actually we can also actually show some kind of false reading on the meters, or there are some kind of taps on the LT lines, like we are actually on the LT lines which are on the secondary side of our transformer. If we are tapping the taps which are known as the kundas, so if we are doing these are causing the non-technical losses, and these non-technical losses not only create a burden for the supplier, but it also produce a burden on the consumer, because ultimately the consumer has to bear it, and he has to bear the load shedding in terms of that energy stealing. So now coming towards the unbalanced loading and how it's occurring. Actually, unbalanced loading is, now we know that in three-phase four-wire system, the loads are mostly the single-phase loads. So it's not even easily possible to predict that on each phase we have a constant loads. It's possible that on one phase we have 20 houses, and on other phases we have 25 houses, and on third phases we have in between 20 and 25 houses. So, and each house has its own load. So with this kind of contribution current flowing from each the phases will be different, and it causes the unbalanced loading on each phases. So due to this unbalanced loading, the current starts to flow through the neutral. The current, when the current starts to flow through the neutral, it causes the increased losses. Moreover, when we look deep into the power system analysis, we found that when the unbalanced loading occur, there are two types of the components which are actually being produced with the unbalanced loading. The first one is a negative sequence component, another is a zero sequence component. Negative sequence components, they are the contributors for the voltage as well as for the current. So means the positive sequence voltage and currents are flowing, and negative sequence voltage and currents are flowing. And how they are disturbing the characteristics of the system, like when the positive sequence voltage superimpose the negative when the negative sequence voltage superimpose the zero sequence voltage, it causes the drift, or it causes the shift in the voltage angle. You know that in the AC signal, the angles are being displaced by 120 degree when we have a symmetry, three-phase symmetry. But with the unbalanced loading, this symmetry is actually being disturbed, because the zero sequence voltage and this negative sequence voltage, they just superimpose each other. They try to superimpose each other with unbalanced loading, and this angle is being disturbed. And how the magnitude is being increased, the magnitude is actually being increased due to the flowing of these two additional components, negative sequence components and zero sequence components. And these two components, when they additionally flow, they actually affect the heating capacity of the lines, and ultimately the current carrying capacity of wires, or you can say the cables which are actually installed nearby premises, is actually being decreased. So what actions we can take to reduce this unbalanced loading? The very traditional method which was used before, I think around 20 to 30 years, that is a redistribution of loads. Means what you can do, you can actually have an energy meter, and you measure the amount of energy or amount of current which is flowing through each phase, and on the basis of that reading, you just redistribute rationally, you redistribute the loads in order to balance them. Another another technique is using the inductive and capacitive circuits. Now, how you can use the inductive and capacitive circuits, like you can connect the capacitors of different rating in a star connected. You form a star connection of capacitors, and with with this star connection, you should connect them in a delta with the three-phase system or three-phase four-wire system of the power system or the distribution system. In this way, what you will do, you will just shift the angle, and moreover, you will also supply the reactive power to the system. So with the shift of the angle, this angle correction will be done, which was happened due to the flowing of negative sequence voltage and zero sequence voltage, and the current contribution, which was the power loss contribution, which was due to the which was due to the negative sequence and zero sequence currents. It can be compensated with the reactive power supplement of the capacitor banks. Which are the capacitor banks? Actually, they supply the reactive power. So these reactive power will be helpful in compensating those losses. Moreover, we can also use the phase shifting transformers. Like, these are the special transformers which are used to shift the phase of voltage from one angle to another. In this phase shifting, you can also compensate these losses. Also, auto transformers are used, but make sure that whatever the type of techniques, which are the modern techniques you are using, it should supply the reactive power, because we have to compensate those losses. Now let's consider the case study in order to visualize the practical scenario. So here is actually the one-line diagram of SEPCO network. It was built in PSS Encall, which is actually a Siemens software, and this one is actually a Gudu, not a Gudu, it was actually a SEPCO network. It has 26 132 kV grid stations, and it is supplying the different cities of rural Sin. And what I have taken a one feeder from this a huge network of SEPCO, and this one feeder is actually consisted of 28 transformers. It's why I have taken this one, because I have found that this feeder, which is known as a Dadi feeder, it is the one of the most heavily loaded feeder of SEPCO network. And there are mostly the unbalances are occurring on this kind. There are also so many feeders on which the mostly the unbalances were occurring, but I found it during the month of July that most of the unbalances were occurring on this feeder. So this feeder is consist of 28 transformers, and it's supplying the different customers on these systems. So this table shows, the table 1 shows the transformer rating for the Dadi feeder of SEPCO network, and we have different 28 transformers of different ratings, and I have found their cumulative capacity. The cumulative capacity is 4,700. So why we are doing this? Actually, the assess point, the point of measurement in the distribution system for assessing the losses is the transformer. Now we will assess on each transformer, how much unbalance is actually occurring. So with this, because we cannot go to the each consumer and we can ask or measuring each consumer, because ultimately the consumers are connected with the transformer. So while measuring the unbalanced loading on the transformer, it ultimately means that we are measuring the unbalancing of the customers. So measuring this unbalance, so this can be measured by using these equations. So these equations, I'll not go deep into these equations. I'll just tell you broadly that what these equations define. Actually, these equations says that the equation 1 like says that how to calculate the power loss, the power which is being supplied and power which is being built, as being said by a presenter before me, the Sanjay Bhanga. You are saying that he has a 8% loss. So this is being calculated by power supplied and power built. So it's percent losses, and how to calculate these technical losses. So this is the equation 2 shows the formula for calculating the technical losses. The technical losses are consisted of core losses, which are also known as no load losses, and another are the copper losses, which are known as load losses. So this equation is actually the combination of these two losses, and they combinedly give the technical losses on the transformer. So this one ET is for the technical losses. And now the equation 3, how to calculate the no load losses, and then how to calculate the load losses. So these are the full equation. The main factor here is the equation 8, which shows that, let me I think we should have a one pointer. So equation, you can see here, the equation C shows a factor Kj. This actually factor is very much important. This factor shows the percentage or the amount of unbalance on each transformer. It will show the amount of unbalance on each transformer. So, and the quantities which are being used here, they are all given and measurable, like R naught over RP ratio. It is for the lines, it is 1 with when the kj is 1.13, and when kj is 1.2, this ratio should be 2. and how to measure the percentage unbalance. The equation 11 is actually used for measuring the percentage unbalance. So while using all these equations and then implementing these equations with the SEPCO network, I found that you can see in the equation table 2 that before the application of balancing method and after the application of balancing method, the losses before the application of balancing method, the losses in the system are 283.89 kilowatt, and after balancing the system, the losses has been reduced to 222.29, means 229.29. So almost 68 kilowatt losses has can be reduced by just balancing the system, by using the capacitor banks, by using the star connected capacitor banks. And how much saving we can do, like you can see that if we are calculating it for 1 year, I have found that for 1 year the total saving on this one feeder, it would be around 2.88 million rupees, so that is around 28 lakh rupees. So you can imagine that with this 28 lakh rupees, if for 1 year we are saving 28 lakh rupees on a one feeder, so if we are doing this kind of calculation or this kind of implementation on all the networks in Pakistan, then how much amount of energy and how much amount of economy uh, we can we can save for our country, or we can actually be an economical country. And you can see here the economical effects which are showing for this kind of SEPCO network. This showing that the total losses, which are, this one is showing the before the unbalancing and after the unbalancing, the technical losses, they are just reduced to 61.6. And on the no load losses, which are the copper losses, the no load losses are actually less. They are 5.89 kilowatts. So on cumulative basis, they are 68 kilowatt losses. So again, how actually, because the capacitor banks again cost you to implement them, and how much cost they are actually causing more when we are implementing them. So I've just produced some table. I have just formed a correlation between the capacitor banks installed and the amount of energy saved. So I found that within the 4 months we can actually produce as much, or we can actually save as much as energy that we can actually accumulate for those the cost of those capacitor which are being installed. Means in 4 months we can recover the cost of those capacitor banks. And these are the facts and figures from the Pakistan. These are actually shared with me by the Mohammad Yunus Daga Sahab when he was here in Sakhar IB University. He paid a visit to us. So he shared with us that the total transmission and distribution losses in entire Pakistani network, it is according to 2017 and 18 data, they are 17.5 in this is for this public data, this is for the public network, means public network including the SEPCO, JEPCO and all, not including the K Electric. And even in 2018 the K Electric has 24% losses, which is actually a private company. So this is actually a big achievement that our people are doing good. Not the SEPCO network, but the people from the FESCO and JEPCO and MEPCO, the losses are very less, like 5% and 8%. Like in MEPCO, the losses they claimed last year that the losses in the MEPCO, the technical losses in the MEPCO are 8%. So it can be possible there. So again, these are the ampere turn and copper losses, which have also been reduced to 22.4%, which were sometimes 25.23%, and they are even less than the Indian power system, which are according to 2016 data, they were 26%, and they are also appreciated in the entire Asia that the Pakistan is working on the power system losses, and we have also reduced and we have also cope up on these type of losses. And this one is a fraction figure, because you know that in Pakistan the people are consuming the energy but they are not paying the bills. So with the formation of new government in 2013, when the Prime Minister Nawaz Sharif take over the system, and he started and he started his concerns about the new projects for the power production and the revenue collection and bill collection. So you can see the losses are actually being reduced with the passage of time between 2013 and 2016, and the bill collection, which is actually very much necessary for running any power system, not any power system, for running any organization, they are necessary. So bill collection has been increased from 88% to 94% in 2016. And now finally the remedies, like what kind of remedies we can implement. So
Mr. Katiara, so we could not hear you. Uh, is your mic right? We cannot hear you now. Is there some technical problem with Mr. Sunny Katiara? But luckily, he has almost wrapped up his presentation. So, but I would hope that Mr. Sunny Katiara will remain with us. Mr. Sunny, I think there is a
and
technical
introduce
problem.
the system.
Uh,
Hello?
Mr. Sunny, can you hear us now?
No, no, yeah, yes, yes, I can hear you. Hello?
Actually, there was a slight technical problem and we couldn't hear you. But I hope that almost the presentation is wrapped up. If you just wrap the remaining part just in 1 minute so we can start with the next presenter
Yeah,
and
it's
then.
done. It's done. It's done. I was just finishing the presentation. I was just on the final is providing the subsidy on the renewable energy sources in order to promote the use of more and more renewable energy sources in Pakistan, because they are green and they are actually the system support. They are providing the system support benefits also to the system, and they can be used as distributed generation. And with the use of distributed generation, we do not need to install new transmission lines. But although we can install them near the load center and they can supply the power to the loads without causing any kind of losses. So there should be a subsidy for the renewable resources, and there should be a ERP, enterprise resource management system for the operational and financial monitoring of the system. And that's all from my side. And thank you.
Thank you very much, Mr. Sunny Katiara, for an insightful presentation.
I'm
So I would
sorry,
now.
actually, I don't know why I have some issue with my internet. I don't know.
It's a common thing. It happens sometimes. But we have clearly listened to your most of presentation, so we are very thankful. Now, I may request if you can stay with us till the question answer session, in which we will pose the
Yes,
questions
yes,
to both of the
exactly.
presenters. Okay.
Yep.
Now, I would like Mr. Shah Zulfikar Haider. In a short introduction, Mr. Haider is the General Manager, Rural Electric Cooperatives under BREB, Bangladesh. He's a professional engineer and holds an MBA. He has 35 above years of experience in electric utility management and smart grid technology solutions. He holds a national award as Best Officer in Rural Electrification Sector of Bangladesh during National Electricity Week 2010. Mr. Hazar will be presenting on solutions for reducing technical and non-technical losses in power utilities and an interesting case study from Narayanganj Rural Electric Utility. So, Mr. Zulfikar Haider, I am transferring control to you, sir. Can you hear us and can you use your controls? So, Mr. Haider, the controls are with you now. Mr. Haider, can you hear us? Mm, sir, Mr. Haider, can you hear us? Yes. There is a slight technical problem with Mr. Heather. We are just controlling it. Stay tuned. Meanwhile, Mr. Sunny Katiara, I have a quick question to ask from you. It has been
Yes.
given to us by our audience from Afghanistan. He says that usually the cost of data collection for analysis of power system losses is very costly. and generally the students and the researchers they opt simulation softwares. Uh, in your
Mm-hmm.
experience, what is the accuracy of such analysis when compared to the actual field results?
Yeah, actually, I have also experienced that. When I was doing research on this kind of thing, actually, I simulated all these things on Simulink, and then I thought that either these Simulink results are correct or not. Then I contacted one of the SDO of SEPCO, and he told me the losses which you have calculated, the losses which I have calculated, they were showing around me that they were showing me it should be around 28%, but he was saying that in real system we have 32% losses. There was a difference of 4% there, and he was saying it's just because of that, due to the environmental condition, that in real time we have a different environmental condition, and in the simulating system you have an ideal system. So it's
Right.
really there are some differences. You are right. There are some differences in the actual data with the when you are calculating all these things in the real time, and when you are simulating in the simulation software, there are certain differences. But they are not the big differences, you can say. There are certain differences.
Okay, that's great, sir. I hope that Mr. Shah Zulfikar Haider is back with us again. Um, Mr. Zulfikar Haider, can you hear us? Um, we are still facing some technical problems with Mr. Haider Zulfikar. I would revert back to Mr. Sunny Katiaria with another question. There's a question from Bhutan. He says that your case study shows lots of savings on unbalanced loading reduction in a utility company. Anything
Mm-hmm.
ongoing in this regard to reduce such losses in Pakistan? Can you share some information?
Sorry, I cannot hear you. Why your voice is just being stuck up in the middle? Can you repeat it, please?
I will repeat the question. Basically, the person is asking that your case study has indicated a lot of savings if unbalanced loading is
Mm-hmm.
reduced in Pakistan. Do you know of
Yes.
any such improvement projects already happening in the country?
No, actually, when I was in talk with Mohammad Minis Daga Saab, he told me that we are planning to do some initiatives, like we are taking some initiatives of installing the smart meters and installing some kind of, but he was not focusing on unbalanced loading. He was focusing on general power system losses. He was not focusing on unbalanced losses. So when I put his attention on these kind of losses, then he said that, yeah, this kind of saving that you show, that this is realistic and we should work on it. And he encouraged me, and he says that you should forward our report. I also shared my report with him, but unfortunately he was, I think, transferred, or he was taking his charge, and now I don't know where he is. But he promised me that he would be working on this kind of. But till now there is no any work that has been done in real system on the power system in Pakistan about these unbalanced loading losses. Hello. Hello.
Mr. Heather, can you hear us now? Mr. Heather, we are still having some technical problems in connecting Mr. Heather. Please stay tuned as we solve this problem. Um, Mr. Heather, may I suggest if you can re-log in into the GoToWebinar and we can try this again. We can actually hear your voices. Maybe if you can respond to our request. Uh, Dear audience, I'm sorry for this disturbance. We are actually in the process of connecting Mr. Shah Zulfikar Haider. At this moment, we are facing some technical problems. We will revert back as soon as the technical problems are solved. Mr. Haider Zulfikar, you're audible? We can hear your voice. Mr. Haider Zulfikar, are you facing some technical problems right now? सर ये इधर ना दोबारा एज ए ऑडियंस कह रहा है मैं ऑडियंस के तौर पे हाँ ठहरे इसको मेक presenter. Okay, so there is a second email ID has come from. Yes, Mr. Haider Zulfikar, can you hear us now?
Show my screen hashtag.
Yeah, Mr. Zulfikar, you're audible to us now.
Full screen can you go back?
Mr. Haider Zulfikar?
Yes, I'm sorry for all the inconvenience from my side. Assalamu alaikum. Good afternoon from Bangladesh, as per Bangladesh and India timing and Pakistan timing. And namaste. Time is quite late. I'm not going to take much time. The topic is reduction of technical and non-technical losses, case study from Bangladesh. The paper was prepared by me and was assisted by Mr. Fahad Haider. He's a graduate engineer from Australia and he's a research and engineer from Benelux Private Limited. And he has got many international publications on renewable energy, energy efficiency, and he's also an international speaker. Loss reduction versus energy efficiency or energy conservation. When we talk about loss reduction with our customers, they are not much concerned. They say that it is your baby. But when we talk to customers about what about saving your electricity bill, but not curtailing your energy needs, they are happy with it. So in order to influence them, we followed the way that a penny saved is a penny earned. You all will agree that demand globally is increasing in a geometric way, but supply is not increasing in the same way. Then again, environmental issues are also there. So what we did that we motivated our customers that you reduce your utility bill, and in return, it is going to help the utility and the country as a whole to reduce its demands. What actions we take to reduce technical losses? We went for power factor improvement both at customer level and utility level. Capacitor banks were installed. Then voltage regulators were installed because we were concerned that voltage, we believe that I square R is the thing. The better is voltage, the less is the current flowing. Then what we did is that we voltage checked the grounding and earthing and wiring of the industries, and connectors were installed, lines were renovated to reduce technical losses. We had over 4,000 three-phase connections and they were regularly checked. Phase balancing is another important issue, which we have done it through rearrangement of feeders. Then old meters were renovated, overloaded conductors were changed, underloaded overloaded transformers were changed, new substations at load center, the meter connections were renovated, line maintenance done to reduce customer outage, And lastly, we went for prepaid smart meters. Then for non-technical losses, uh, illegal connections were removed. We could very good administrative help. We had mobile magistrate courts from local administration. Any illegal consumer was brought under billing and metered. Then not running and defective meters, because they are meters with time, the life is gone. We regularly changed. Another important aspect was clearing the right of way of all distribution lines and special drive and night operations, because mostly we found that electricity users used to misuse electricity during the night time. Then there are other losses also. 100% these can be outside technical and non-technical losses. 100% proper meter reading and bills were served. Meter report were made regularly, prepared and checked regularly. Then we used increase of solar panel, because increase of solar panel means you reduce your demand on the grid. And every Sunday we used to welcome our consumers. We used to have special public hearing day where they used to tell about their grievances, if any. Then we had extensive motivation meeting at school, college, bazaars, and union councils regularly. This is the scenario of the cooperative, which we had this. We had this piloting. Then there's a category of consumer. Our consumers were around 220,000, and we had consumption around 70% industrial consumptions. First of all, we hit the power factor. For power factor, what we did is that, you know, that there's a two part, active power and reactive power. And the cos theta, the less is the this angle, the more we get the power. So this, what was the effect of power factor? E is equal to VI cos theta. For transformer loss, a customer, if he installs a 1000 kVA transformer with power factor 95%, his output was 950 kilowatt. But same transformer with 80% power factor had only 800 kilowatt output. So for 15% less power factor, there was net loss of 150 kilowatt output. And in Bangladesh, the customers, they have mandatory, they have to install 950 kilowatt. They have mandatory power factor is 95%, and for utility, it is 90%. Then we went for capacitor bank and voltage regulators. We installed capacitor banks not at the customer point also, but in the lines also. And we had voltage regulators to improve and stabilize the voltage. Again, the other way I will say, what were the losses to the utility? For 80% power factor, if we have got 1000 kV at our substation, the customer is billed 800 kilowatt hour for 1 hour consumption. But with power factor 95%, we are getting bill of 950 kilowatt hour. So with this, for 80% power factor, the utility is going to get 150 kilowatt hour less bill only for 1 hour. Then what we did, that for industries, grounding is an important factor. We made teams, technical teams, and voluntarily they went to each industry and they checked their grounding and wiring also. The customers were very happy, they cooperated with us, and we had our phases of balance, and ground loss was also negligible. This regularly we had industrial wiring checking. The other thing we did, that not running analog meters, which changed to digital meters. And the best thing was that 3-phase meters, industrial meters, were regularly checked almost 3 to 4 times a year. And we had all our meters, whether industrial or domestic, all outside the premises. It had two advantages, because in the house is locked, our meter man cannot go and read the meter, and pilferage percentage is also there. Energy saving was another thing. We motivated our customers that if you save electricity, if you use LED and energy CFL lamps, your consumption is less, and in return, our current flow will be less. And in Bangladesh now, almost all the lamps are energy saving lamps. Tree cutting, or we call it right away, is another important thing. It reduces our technical losses, and again, interruption is lost. In the left side, you will see that a line in between the trees, outage is more, interruption is more, losses are more, The right side is a clean line where interruption is very less. And loss reduction through digital technologies. Now is the age of digital technology. Digital technology was imposed both at the customer level and at utility level, and we found that our losses are also going down. In Bangladesh, we had one thing that for any new connections, we had a set rule of providing solar panels. Industry and commercials, they have to have their own electricity through solar panel for 50 kilowatt, and above 50 kilowatt, it will be 10%. Only for garments, because garments is one of the main export product of Bangladesh, it's 5%. And for residential, for all load above 2 kilowatt, we had 3% solar panels to be established. This way customers were accustomed and rooftop solar gained popularity. Solar panel had another advantage. Instead, when there were outages, maybe due to load shedding or interruption, customer had his own minimum electricity through solar panel. Now, in addition to that, we installed, they were twisting in our lines. We removed the twisting lines and we put connectors there. The lines were renovated because with time the load increased. We changed the customer, or we constructed parallel feeders, and this way we did the technical losses were reduced. Then phase balancing was another important thing which I said earlier also. Overloaded conductor was changed to proper size. That underloaded and overloaded transformers were changed to proper size. This is very important because in rural area we have small transformers, 10, 15, 25, 37 kVA transformers or 50, and we found that with the improvement of the economy of Bangladesh, the load is increasing. So we had a massive plan of transformer augmentation. We had detailed study of a load growth through technical experts, and we had new substations at the load center. Another thing we do regularly, that meter service drops are renovated. Line maintenance is done regularly to reduce the outage. And now the thing has come that prepaid smart meters have come up. You get the bill in advance and your losses are also reduced. Then the other thing, there were technical illegal connections were removed. We had mobile magistrate courts from local administration. Bangladesh government has got very strict rule that every month, the departments which require mobile code, they should at least have one mobile code in the field. And other illegal consumers, I mean, all other illegal consumers, whatever be the type, we bought them under billing and gave them the meter. Because you need electricity, it is your fundamental basic right. So why not bring him under billing? And special is a very unique thing about electrification of Bangladesh, that we have special night operations to check illegal use. Then meter reading and billing is very important because your system loss, bulk system loss starts from first to last day of the month. But for other consumers like domestic commercial, you take reading all through the month. The more it is accurate, you less accurate will be the loss. And we ensure one thing, that all our customers are billed every month and they receive the bill. In case of any problem with any meter, whether it is fast or it's low consumption variation, we call it meter report is done, and we get it checked through engineers on the ground. Customers are most valuable or invaluable to any utility. So what we did, every Sunday, we had special public hearing day, and where all the customers used to come and give the grievance. But another thing is that in every utility, we had called one-point service or one-stop service, where anybody can come anytime and give his grievance and its problem is solved. Motivation is very important nowadays, and we found in utility that we had regular motivation with schools, colleges, Hard Bazaar, and union councils. And we found that people attitude changed and they they started understanding what is energy losses, what is energy saving, and with their cooperation, we reduced our system losses. This I will give an example. What is the effect of power factor? Say January 10, our power factor was 87%, system loss was 12%. But now you September 12th, power factor was 97%, system loss is 9%. It is single digit. Power factor has got very important role both for customer and for utility. With improved power factor, I get more kilowatt hours built, and again my voltage is better. This is an example here. System loss increase. This I will share that with the improvement of our system and massive by this piloting, our system loss, it was 15% in 2006-07, and by 2012-13 it came down to 9.15%. It was found that we had a massive saving of 1.1 million kilowatt hours saved if only 1% system loss is reduced, which is equal to US dollar 0.73 millions or Bangladesh taka 60.8 million. So this is a massive saving. There's a comparison on the left from Narayanan people where we had this piloting, and the other cooperatives, the Ghazipur, Dhaka 1, Dhaka 2, they are all similar utilities having industries, but their losses are 12, 11, and 13, and one which had this massive piloting for to reduce losses, the loss was only 9.15%. In terms of money, you see, the more you save losses, the more you sell electricity and more is your income. So if you compare from 2008-09, it was 349.948 million to 12-13, it jumped to 1870.10 million taka. This is how we did motivation. We started from administration. We had special meeting in district commissioner or district collector office, which was attended by member of parliaments, DCSP, and head of all departments. In fact, I'm grateful to all organizations and the local administration, but without their active support and political support, it would have been difficult to implement this piloting project and have success. This is a picture that we had the motivation meeting at Union Council level, where elites came and we explained him what is electricity, how you save it, what is your benefit, what is utility benefit. Then there's a motivation meeting held in school. We regularly have these short-term meetings where we explain about energy and energy savings. This is another motivation meeting conducted in another school. And though these are in Bengali, I just saw the clips there. We utilize print media to motivate the people about energy savings and reducing losses. This I will give comparison. In 2010, the peak hour was 178 megawatt hour, and we had a saving of 14 megawatt, and this was presented in our power division ministry. And by 2013, what we found that our demand increased to 237 megawatt, but actual peak was 220 megawatt. Energy saving was 17 megawatt, and with diversity factor 60%, we found that our saving is 29 megawatt. So this is a big saving. And when your demand goes down, in case you have got load shedding, it is also minimized. This comparison between today in terms of finance, that what is the sales difference you can see. And this is the comparison to 2012-13, comparison between the same three utilities. This is operating margin and the cross subsidy. In Bangladesh, we have got one very good system. Those cooperatives electric cooperatives which make profit, a portion of the profit is given to those cooperatives which are running on loss because of the terrain or customer pattern. That's all from my side. Thank you very much.
Thank you very much, Mr. Zulfikar Haider. It was an insightful presentation from your side, sir. We have a certain number of questions to ask from you. So is the first question from Pakistan. The question is that how do we rearrange the balancing of transformer loading once a certain locality has been connected for years?
Yeah, that was a challenge, but in Bangladesh, what we had did, we have got master plan and we had the block load study in the field level, and there are two sort of things we experienced: the massive growth of industries, and then you have their own new system there. And another thing we find that that with the improvement of the economy, the customer pattern has increased. So whenever we construct any substation, we had provision to have future expansion, at least 2 to 3 new feeders could be bought out. And again, we had when we had prepared the master plan for any utility, we had a load forecast for at least next 20 years. We constructed those constructions, substation maybe after 5 years or 10 years, but we had the scope. This is a very expensive matter, and but without government support, it is difficult, because in Bangladesh, about new line construction, right away is a problem, but we had extensive government support and local support, so line construction wasn't difficult. And another thing is that we are going for 100% electrification. It's a new thing. So customers, people also helped us sacrificing their land for new line construction. And about line cable changing, it is very challenging. We had multiple circuit. We had 2 circuit, 3 circuit, multiple circuit lines. And yes, it is a challenge to change the cable, but we are doing it.
Okay, sir. In fact, part of your answer leads me to the second question, which is shared from India. That are there any regulatory conditions to reduce utility losses on yearly basis in Bangladesh? And if such investments are there, are they funded through government or they are recovered from consumer in terms of rise of electricity tariffs?
Our utilities, RAB, started one thing, we call it performance target agreement. Each utility is given target for system loss, bill collection, expenditure per kilometer, expenditure per customer. There are around 70 to 20 targets are there given to all utilities. And if we achieve those targets, we are given special bonus. And you will be astonished to know that if we fail in those targets, we are even penalized and part of our salary is deducted. And it brings a competition among the utilities, and we found that the most of the utilities, they have achieved their target. Experience says that cost of constructing 1 megawatt of power plant costs more than $1 million US. But if you save 1 megawatt of power, it cost is less than 1/3. So we found that you don't need extra funding, because when you reduce your losses, your return is much more than your investment. So what we found that our investment was less than 10 million taka in this piloting project, and our return was more than 20 million taka, because in terms of revenue. I think
in fact, that was a very interesting regulatory enforcement that you shared. Sir, I will have a last question to ask. It's from Pakistan again. That what do you think? How much we can influence the diversity factor, especially in case of Bangladesh, through demand response programs? And is it doable practically?
Yeah, it is. You have to go for demand response. You don't have any alternate, because now the question of quality and continuous power has come up. We found that when we gave power for 24 hours, there were outages are now very less. We find that the customers are insisting that we need to have proper voltage, harmonics levels should go down. So day by day, the public need is increasing, the demand is increasing. So this way we have to come up. It is a continuous process. In fact, what to say that you have to go for improvement, you have to go for technological change. With time, you have to go for smart meters. Then smart meter, it is very easy to say, but very difficult to implement. Then renewable integration is another question, because today's power sector has become very complex. We are telling that you have rooftop solar, this reduces your demand, you have your solar plants, but its variation and its integration is a challenge which we utility people are facing. Other people don't understand that whatever what you supply, it has to be matched with your production. It's a real challenge round the year. And customer demands are increasing. Say in Bangladesh, we do not allow big industries to run from peak hour, say from 6 p.m. to 11 p.m. At 11 p.m. night, we found that the sudden jump of few thousand megawatt of electricity. So you need to have spinning reserve for that. Spinning reserve means your cost is increasing. So whatever you say, in most of the countries, electricity supply has to be subsidized. It, it may be a direct loss to, but indirect gain is that your economic losses are much more. In Bangladesh, we had a study that cost of not providing 1 kilowatt hour of electricity was around, say, 15 cent. But economic loss of not providing electricity was more than 50 cent. So you have to follow that path.
Indeed, sir, indeed. So that ends our last session, sir. And thank you very much for joining us in this webinar. So I would now conclude this webinar with this information that all the presentations delivered in this webinar will be shared on Sark Energy Center website, which is www.sarkenergy.org. We would love to hear from our audience their suggestions and comments for further improvement, and any suggested topics of their interest which is relevant to SARC region and the focus of SARC Energy Center, on which the audience may want us to arrange a future webinar. We would be glad to do that. With me signing out, thank you again for joining us today and looking forward to see you next time. Have a very nice day.